Hey guys, welcome back to my YouTube channel. So in this class, they are going to see about the another very important thing, that is a breakdown or diode. So there is two types of breakdown that will happen. So one is one is Zener breakdown, and one is Avalanche breakdown. So the below shown is the normal breakdown, that how that will happen in a diode. So this is a IV RVI characteristic curve. So the diode will behave. The output will be some reverse saturation current will flow after some increase in voltage potential. But when we keep on increasing the potential, at some point the diode will be breaking. Means that will loses its ability to do. So after that, the diode will not be useful for any kind of purpose. So after that breakdown, it will not be used in the as the normal. So there is two kind of things. So once that will be diode will be burst, that will not be used. Another one, in some breakdown, some near to breakdown region voltage, we can make that to use for some kind of applications. So here let's see about Zener breakdown first. So Zener breakdown. So Zener breakdown occurs in relatively heavily doped PN junction diode. So so the Zener breakdown will usually occurs at heavily doped PN junction diode. It will not be as like normal PN junction diode, which will happen in a heavily doped PN junction diode. So as it is breakdown, so it will only in the reverse bias condition. So when we keep on increasing the reverse bias voltage, at some point of time, there will be the diode will breaking down, and at the constant potential, we will be able to get more current in the diode in the reverse direction. So in a heavily doped PN junction, the internal electric field will increases. So in a heavily doped PN junction, the electric field will be increases, which will be much greater than normal thing. And if the diode is subjected to reverse bias, if we increase the reverse bias voltage condition there, then the plot will follow the same characteristic curve as discussed in the reverse bias junction. So this is the condition when our reverse bias applied voltage is much less than the breakdown voltage. So every diode will have a breakdown voltage. After that only it will be breaking down. So now if the reverse bias is further increased above the breakdown voltage, if the reverse bias is further increased, then the net electrical field inside the depletion region will be high. So the electrical field will increase. Okay, so it will be very high and sufficient to break the covalent bond. So breaking of covalent bond will happen. So breaking of covalent bond inside the depletion region. So once this is done, hence the carrier concentration will increases rapidly. So after, because of this, N and P will increases rapidly inside the depletion region. So this will make the I naught to increase tremendously. So this is the flow, that how the current is increasing after the Zener breakdown. So here you see the current is keep on increasing, right? So this is because of this behavior only. So this is what the Zener breakdown things that usually work. So this kind of application, you guys may see that reverse saturation current will not be used in any kind of cases, but there is some kind of application that we can use in things. So the Zener breakdown is the condition where we can use it for voltage regulation in a circuit. Here you see at the particular voltage, it will not be even in the ideal cases, there will be some kind of slope will be there, so that we need to take into picture. So some kind of slope will be there, that is because of the resistance behavior. But in ideal device, the device will the ideal, in ideal case, let me draw an ideal devices, ideal case how the breakdown will be there is that, so it will trace the curve as like this one. So once that is reached the thing, then it will abruptly go down. So this is what the ideal thing. So ideally it need to be like this, but practically this is what the things that is available in the market or even in the any kind of scenarios. So this is what the Zener diode. So let's take about avalanche breakdown. The second thing is the avalanche breakdown. Okay. So avalanche breakdown occurs relatively lightly doped linear junction diode. So here it is lightly doped, lightly doped, lightly doped non-uniform junction. The we have seen that uniform doped junction and non-uniform doped junction. So in the non-uniform doped junction only avalanche breakdown will happen. So here that is same thing. So how the Zener breakdown occur, but the thing is that it will be happen in a lightly doped thing. So in avalanche breakdown, what will happen is that it will be getting multiplied. So the high energy thing that will be carried and multiplying the thing. How the avalanche breakdown process will happen is that in lightly doped PN junction diode, the internal electric field is small. So internal electric field will be small, will not be that big as like we discussed in Zener diode, right? So it will be small. And if the diode is subjected to reverse bias condition, the reverse bias is increased, then the plot will same. Here the condition is the it is less than breakdown voltage. Okay. So if we increase the reverse bias condition further, then the high energy electron collides with the atom. So collision will happen. If we take electron collides with the atom. Okay, and able to knock out to the outer orbital. So free electrons will be formed because of this. So free electrons will be formed. So because of this, this free electron will kick another one free electron, and this process will multiply. So secondary. So more free electrons will be formed. So process will multiply. Process will multiply. Okay. So hence what will happen? N will increases further. Because of that, I will also increases. So this is normal avalanche breakdown, not like Zener diode, which is heavily doped. Here it is lightly doped breakdown condition. Since the energetic electron collides with an atom and generating many other electrons, like many more free carriers, this process is called impact ionization. So it will follow a thing called impact ionization. So it is called as impact ionization. So this is one of the very important question. You guys can note it. So where a Zener diode mechanism is field ionized process. So in Zener diode, that is called field ionized process. So Zener breakdown voltage is a negative temperature coefficient, and avalanche breakdown is a positive temperature coefficient. So guys, you guys need to note this one. Since Zener breakdown is due to sudden breaking of covalent bond. So when temperature increases, the covalent bond is early, the breakage will be easier. So therefore we will get the breakdown at lower voltage. So whenever temperature increases, we will be getting the breakdown voltage will further reduces. So how the Zener diode will be represented as similar to that thing, the same, but an Z kind of thing like this way. And Z kind of thing will be added here. So this will be used to represent the Zener diode. So this is the diagrammatic representation for the Zener diode. So I hope you guys able to understand the things, right? So this is what the backend theory began the Zener diode. So this will be majorly used for plenty of applications in things like as I said, right? So voltage regulation is the one of the major thing where we will use the Zener diode in many of the cases. So in the next class, we will see more on how to discuss further things like how the recombination process and how the indirect band breakdown voltage, how to find the breakdown voltage things. So that thing we will be discussing in the next class. So mostly the breakdown voltage will be reciprocal to that of doping. So that thing we can take a picture. The breakdown voltage is that. So breakdown voltage will be always inversely proportional to doping. So if it is more doped, then the breakdown voltage will be quite lower because there will be more chances for the ions or bond to get break, so that the process will be much more simplified. So that is why when we take into the application, then the breakdown voltage will be inversely related to that term. So I think plenty of the concept that is covered in the PN junction diode. So from next class, we can even start with the other kind of special diodes, like the application of solar cell, photoelectronic cell. So those kind of applications also we can start. So from next class, we will be starting with special devices together. So like, share and subscribe channel. If you guys able to understand this all the topics, please ping in the comment section so that I will be able to know that how lagging or how fast you guys can able to grasp the concept. So please Like, share, and subscribe channel, guys. So stay tuned. Stay tuned for next lectures.